Hello, my name is Mohammed. I will present the paper entitled Design and Implementation of DS-CDMA Educational Laboratory Board using FPGA and High-Level Synthesis. Co-authored with Ahmed Hamid. We are from the University of Babylon, Iraq. The paper is structured as follows, with the main sections: Introduction, DS-CDMA System, Implementation Methodology, Results and Discussion, and finally the conclusion. Introduction. First, multipath fading is one of the most important effects in communication system. It degrades and limits the system performance. DS or direct sequence CDMA is one of the techniques that can be used to mitigate its effects. FPGA or Field Programmable Gate Array is a reconfigurable integrated circuit that can be used to implement the required hardware. Traditionally, FPGAs are programmed using HDL or Hardware Description Language. However, in this implementation we utilize a high-level synthesis-based approach or HLS, which is used high-level language like C, C++ to implement the required hardware. It offers higher flexibility and fast development time. This work aimed to propose a flexible implementation and use it to implement the DS or direct sequence CDMA system. It aimed to provide a deep and intuitive understanding of the system and investigates its properties. DS-CDMA system. The figure shows the various parts of the system. Here we can see the transmitter block diagram, the channel block diagram, and the two different types of the receiver, the conventional receiver and the rack receiver. Implementation methodology. The implementation consists of 3 steps. First, the hardware design, which is done using Vitis HLS platform, utilizing the high-level synthesis-based approach. Then, the designed hardware is integrated in a block-based design using Vivado platform. And finally, microblaze soft core processor is used to implement the required algorithm, and it's programmed using Xilinx Vitis platform. All these platforms are available for free from Xilinx. Implementation methodology. Here we can see the block-based design on Vivado platform. Here we can see the custom designed hardware using HLS, the microblaze soft core processor, and the other hardware that used in the implementation. After completing the block-based design, synthesis, implementation, and bit stream generation was carried out, and the configuration is downloaded to the FPGA board. Then, the microblaze is programmed using the Vitis platform to implement the required algorithm. This figure shows the implementation's prototype and its main components. Here we can see the FPGA board, the display, the switches to configure the system, and here we can inspect the various signals. And we have also an R2R digital to analog converter. This figure shows the proposed front layout of the board. We can see the different parts of the system. Here we have the transmitter with the 3 users, the channel, the 2 types of receivers, the display, switches for configuration, and banana connectors to inspect the required signal. Results and discussion. First, the bit error rate is evaluated for 3 users at the transmitter and user 1 at the receiver. And the bit error rate value can be read directly from the onboard display. Here we can see the bit error rate value, and the other window can show the parameter configuration. First, the bit error rate is evaluated with conventional receiver. This figure shows the bit error rate with conventional receiver and active wide Gaussian noise channel only. Here we can see the performance of processing gain of 31 and 127. And as we can see, as the processing gain increases, the performance is enhanced, and it is in alignment with the theoretical value. This figure shows the performance of the bit error rate with active wide Gaussian noise and multipath channel with 4 paths. And here also we can see, as the processing gain increases from 31 to 127, the performance is enhanced, and is in alignment with the theoretical value. Hence, the immunity of the system against multipath fading is demonstrated. Then, the bit error rate is evaluated with rack receiver. First, with a processing gain of 31. Here we can see the performance of the conventional receiver, its theoretical value, the rack receiver and its theoretical value. And as we can see, using the rack receiver enhanced the performance. Although it's not in alignment with the theoretical value, but we can see the performance enhancement. Finally, using processing gain of 127 with rack receiver and 4-path multipath fading, we can see that the rack receiver enhanced the performance. This is the curve for the conventional receiver, and this is for the rack receiver. And as we can see, it's in alignment with the theoretical value, and it is enhanced. This is because the rack receiver utilizes all the multipaths fading. Hence, it harvests the energy from all the paths and use all the paths at the decoder. On the other hand, the conventional receiver uses only the principal path and ignore all other paths. This figure shows the performance of the rack receiver with 2, 3, and 4 paths multipath fading. And as we can see, as the number of paths increase, the performance is enhanced. Here for 2, 3, and 4. And as we said, the rack receiver harvests the energy from all the paths and uses all the paths at the decoder. Hence, it is enhanced the performance of the system. Various signals can be inspected. Here we see the input data and the subroutine code. Here we can see the transmitted and the noisy received signal. And zooming in, here we can see the transmitted signal and the received signal with active wide Gaussian noise only. And we can notice that the effect of the channel is only an additive effect. However, using active wide Gaussian noise and multipath fading channel, we can see the distortion on the signal, and we can notice the dispersion effect of the signal. And here we can see the input data and the output data with low signal-to-noise ratio, and we can notice the bits error. However, in increasing the signal-to-noise ratio, we can rarely notice any error bits, and we can see that the performance is enhanced. Conclusion: the work proposed and successfully implements the direct sequence CDMA system. It demonstrates the system immunity against multipath fading, and it demonstrates the effectiveness of the rack receiver and how it enhanced the performance of the system, and it's enabled investigation of the system, and it's give a comprehensive understanding of the direct sequence CDMA system. Future work could utilize the proposed methodology to implement other systems, or could further develop the proposed implementation and increase its capabilities. Thank you for your attention.